Hi guys, today we're going to take a look at one more thing that I want to containerize, and this one is FreeBSD. Now this is a fairly niche operating system that has quite a bit of use in academics and also in some server products. I also use it at home in the form of pfSense, which is an open source firewall based on FreeBSD. But in any case, I wanted to try to install FreeBSD, the entire operating system, inside of a Docker container and see if that would actually work. And it turns out it's actually really easy to do. Of all the ones that I've tried to containerize, this one was probably the most seamless install, and it was surprisingly performant inside the container considering the constraints of what it's actually doing. So let's just go through the process of how I did this, and then I'll show you it actually running inside of a container. So this is the Dockerfile for this. This is pretty straightforward. This is based on Ubuntu 22.04, and it's using apt-get to install a bunch of different packages, including things for the sound, and it's using Nginx. It's installing some common utilities like unzip and some certificates and things like that. It also installs qemu and no VNC. Now, Nginx in this case is basically just a reverse proxy for the sound stack and also for the audio stack, so that you can end up with two different stacks but coming back to a single URL. This right here is basically reconfiguring no VNC to have audio along with it. No VNC is the VNC client, which attaches to this, which is using Turbo VNC for the actual VNC server. And Virtual GL allows us to have 2D and 3D acceleration inside the context of Turbo VNC. So it makes the graphics more smooth. Now, this just configures no VNC right here. And this is so that it will start up some kind of terminal that is going to be inside of the GL desktop that we have running on top of X. And so Turbo VNC just intercepts all of that and then serves it up to the no VNC client that enables you to see it in a web browser. So that's what this is doing. And I'm using LX terminal just so that it starts into the terminal, and that way you can then run commands to actually create your virtual machine and also interact with that virtual machine once it is up and running. And then of course it's orchestrating all that with supervisor D, which is a common supervisor daemon that runs in a Docker container that will bootstrap all of these other components that are used in this one, including the wrapper for no VNC, Turbo VNC, the sound stack, Nginx, and a ton of other things that this thing is doing. So there's a lot going on here, but all in all, it actually gets a system up and running and is pretty performant once you do all that. So let's build this and then we'll run it, and then I'll show you how to install FreeBSD into this guy. Building this is a piece of cake. Just run docker build and then tag it -t. There's no additional parameters. So I'm just going to call it qemu-BSD like that, and then use the dot because I'm in the folder to point to the local Docker file here, and then that will build the actual image, if I actually could spell build right. And mine will build quickly because I've actually already built this image, but it will take a few minutes to build because it's got to install a lot of stuff, and that's going to download into the container image itself using apt-get. So it depends on the speed of your internet and also the speed of your computer. So give it some time to build, and once it's done, you'll have the image up and ready to go. I'll push this image to a Docker Hub repo, and I'll also put the final product for BSD as well to a Docker Hub repo so that you can download those if you don't want to go through the process of building it. But installing this is actually part of the fun of this. So I'm going to walk you through it, and then I'm going to show you how to take a snapshot of it so you'll have your own implementation of FreeBSD in a container. So to run this, it's pretty straightforward. So just use docker run, and then you can use two parameters for this. I'm going to do a port forward. So I'm going to do port 8080 and port forward that to port 80 in the container. And I'm going to do a volume mount. So I'm going to mount this folder right here inside of the container. And that will allow me to have an ISO file in the container. So I'm going to do that to just mount the volume there at /isos in the container. And then I'm just going to tell it to use that image I just built using the build command. So that will then start this up, and as it starts up, you'll see everything come up, and that's what we want to see. Now we can go over to the browser and then pull this up in the browser, and we can start working in the browser context. So to get the software, go to freebsd.org and you can click on Get FreeBSD, and then scroll down here and you can choose either AMD 64 or i386. Either one of those would work, and I can get this one in particular because it's the one I'm going to be using for my demo here. And you can download the DVD version of this. That will have a full repository of software on the DVD. Or if you just want to get the CD version of it, you can get this one right here, which is a more pared down version of the ISO. Either one would work. I'm going to go with the DVD version. And once you have that, you want to put that into the same folder that you mounted into the container so that that ISO file will be available inside the container. So that'll become important in just a second once we get this thing up and running and ready to install. So once you have that downloaded, you can go to the IP address of the instance that has your Linux context for running Docker in, and mine is WSL, so it's going to be this IP right here. And this will give you a directory listing for the root, and this one is going to be vnc.html, which I'm going to open. And then I'm going to click on this and type in the password that I put into the Dockerfile, which in this case is password1. And it's going to launch lxterm right here. And this is just an LX terminal that I told it to launch from the Dockerfile once I logged in. So this is ready to put commands in. Now, of course, there's nothing installed yet. I need to create the VM and also create a virtual hard disk. So those are the next commands that I'm going to run. Running the command to create a virtual hard disk is pretty straightforward. So you want to pick a location. If you want to package the virtual hard disk with the container, put it in a folder that's a part of the container's file system. Otherwise, put it external to the file system, which is what I would typically do in an environment like this. I would have the BSD virtual hard disk outside of the container. But since I'm going to push this later on so you can play with it, I'm going to put it inside the container. So to do that, I'm just going to use the paste functionality inside of LX terminal, but I'm going to use the clipboard feature that's built into Node VNC to run this command right here, which is going to call qemu-img, and that's going to create a new image. It's going to create a disk size of 10 gigabytes called bsd.raw, and that is now ready to be pasted in. So I'm going to paste it right here, and this will create just something in the root called bsd.raw. Now that that's done, I am ready to actually run the virtual machine. Now, running virtual machines, there's a lot of ways you can do this. I'm going to be using the software binary translation for running BSD rather than using hardware-assisted virtualization to run BSD. And the reason why is it makes the container a lot more portable if you do that. But however, if you want the maximal performance, you can set a flag in the command I'm about to show you called enable KVM. That requires that KVM be installed on the host. But with that, it will give you hardware-assisted virtualization, which will make the VM run faster. But this one doesn't have a lot of overhead, so it actually runs fairly well without the hardware-assisted virtualization. And this will allow you to put FreeBSD in a container on virtually anything that can run a container. So that could be something like Azure Container Apps, for instance, or you could run it in an app service. All of those will run containers. So lots of options there. So for this, I'm going to paste in a new command. It's going to look like this. Not that command, that's the one I just did. And this one right here. And this one, it's using QEMU system x86-64, which would work with 32-bit, or it will work with the 64-bit, depending on which one you downloaded. Then you tell it how much memory you want. 2 gigs should be plenty for BSD. It's pretty low system requirements. You're going to point the HDA to the virtual disk that you just created using qemu-img. This is the path to your ISO that you downloaded. So mine is ISOs / FreeBSD 13.2 release i386 dvd1.iso, and you'd say dash boot disk, but if it can't find anything, it'll default to the cdrom. Then I want to pass it a NIC parameter, and that's just basically telling it to use user mode rather than try to mount one from the host. And that allows me to have a network stack that's independent of the host network stack. And then if I want sound, you can do dash sound hardware, and I'm going to use AC97, which is widely supported by most every operating system out there. Let me log back in here because my session timed out. And we'll rerun that command and go with this right here. So this one right here will then allow me to paste it in. So I can push this back here, and this will run that command inside of lxterm. So this will start the VM and start the installation process. So walking through the installation process is pretty straightforward. You just start it, and that's going to start running it in this particular mode. Installing BSD is actually really easy to do too. You're not going to have a lot of rigmarole to this. So you just boot off the ISO, and then it's going to ask you for a keyboard. And you can scroll down to whichever one that you're using. I'm using United States of America keyboard format, and then I'm going to continue with that. And then this is the host name, so I'm going to call it blaze-bsd or something like that. And then let this work its magic on that. I'm going to use ZFS for the file system, and then it's going to find some disk, and I'm going to click install here. I don't need any RAID. I'm going to use the qemu hard disk that I created and use the full disk, and that's just going to partition it. There's currently nothing on it, so it's not going to kill anything. And then it's going to install the operating system. Once you're at this point, you just sit back and relax and let it do its thing. This is actually a fairly quick process, so just let it take its time and you'll be done in a few minutes. And then we'll be back up and running with BSD. Then we can install some software into it, and that's what we'll do next. So after the installation kind of goes through its thing, you're going to put in a password. For this one, I'm going to put in password 1 and then type that in again. It's super secure. And select this network interface, and I'm going to use IPv4. Let's see if it'll get an IP address for this particular VM. And after, I don't need IPv6, and that's probably okay. I'm going to use Americas and the United States for my time zone here. So this would have to be something that you would have to change or set. I'm going to use Eastern, and that's the current date, that's the current time. And all of that looks good, and I don't really need to add anything else. I might need this in a minute, but the rest of that's fine. And that's good. And we'll don't need to add any other user accounts, and then exit the installation, and then it will ask me to reboot, and everything will be installed once it reboots. So after you shut the machine down, you'll need to modify the start command so that it doesn't boot that cdrom anymore, so that it'll boot off the CD. So we're going to basically just edit this particular command right here to remove the cdrom, and then we're going to start this with this command right here. So let me slide that back and get a command prompt, and then paste that in, and this will just boot off of the disk that we did install for all of the software. So this will boot into just a raw login prompt that is BSD installed with pretty much no software. So it's a very minimal installation. So with that, we can then install something on top of it, which I'm going to show you how to install a desktop on top of it, such as XFCE. But there's, of course, a ton of other software you can install on BSD. It's a fairly rich software ecosystem, but I'm going to show you how to install the desktop just so you see, a fancy GUI inside of a Linux container running on WSL on a Windows host. Okay, so the VM is booted for the first time. I'm going to log in as root, and I'm going to provide that password 1 that I entered. And so you can see that it's pretty much running everything as you would expect. So with this in mind, I want to install XFCE, which is just a lightweight desktop environment. So this is just going to use some of the standard package management features built into BSD, similar to what you would get in something like Ubuntu or something like Red Hat with Yum or apt. Still, this is a little bit different in that it doesn't necessarily install all the dependencies for you when you run these commands. So I'm going to basically just run you through the commands to install this to show you that it does work. And you can then use this to install other software as you see fit. So I'm going to start off with Xorg, which is the X server, which is the basis for most of the desktop environments in FreeBSD and Linux for that matter. So I'm going to install this, and then we'll also install a couple other packages. Okay, now that Xorg is installed, I'm going to install a small package called slim, and pkg install -y slim, and that will only take a few seconds to do. And then I'm going to install a package called XFCE, which is the actual desktop environment that works with Xorg. So pkg install -y XFCE, and that can take some rather lengthy amount of time to install like Xorg does, but just sit back and let it finish its thing. Okay, now that that's installed, I'm going to do one other final package, and that is nano. Now, this is going to be used to configure some of the config files for XFCE and Xorg. So let's go ahead and install nano. This should only take just a second to do. You could use VI if you like VI. I'm just not a glutton for punishment, so I tend to use nano as a alternative because it's straightforward. So the first thing I'm going to edit is something called rc.conf. So that is basically a configuration file to control some of the startup services on a FreeBSD system. So I need to enable a couple of things on this that aren't enabled by default. So mouse D is enabled. I need to enable dbus and also something called HALD. And then I need to set slim enable because we installed that. And I think that is all we need to enable that's not already turned on. So Control O, enter to save it. And then I'm going to edit one other file, but I need to create it. And this is the start script for XFCE. So this goes inside of the default folder. So tilde, and then I'm going to do xinitrc. And this will then start up the XFCE session. So I'm going to do exec XFCE, I can't type today, XFCE 4, and then do dash session. And that's the executable that will load once I log into the system using the UI. So with that, I'm going to save this and then exit. And now I can reboot. And upon reboot, I should be able to log into a UI. So instead of seeing the text login, it should see a graphical login instead. So let's go ahead and reboot, and we'll come back when that's done. Okay, now that everything is installed and I've rebooted, you should see a screen that looks something like this. So if I log in, I can run as root and then put in password 1, and that will then start the desktop environment. So I'll let this start up, and we should see some software that's pre-installed, but of course it's not going to be a fairly basic set of software, and of course you can add to this depending on your need. But in any case, it is a UI on top of FreeBSD. FreeBSD is, of course, a pretty versatile operating system. So now that I have some software up and running here, you can see that it does work okay. It's not the snappiest performance in the world, but it gets the job done. I'm not going to complain too much about this, considering that this is kind of like Inception. I have a Windows host running WSL, which is essentially a Hyper-V VM. And inside of that, I'm running Docker. And inside that Docker container, I'm running a FreeBSD virtual machine. So there's a lot of layers to this. And even with all that, it still runs pretty decently in any case. So this particular desktop is XFCE, and it's running a fairly lightweight environment, and you could use other ones, of course, but it's probably not what you would use. In any case, if you were using something like this, you could definitely use XFCE if you wanted to test applications in FreeBSD inside of a Linux container that is running a BSD VM. You could also run the counterparts for this that are just things like daemons like Nginx or web servers or databases that run on BSD. You could definitely test software in that way. And there are just other kinds of cool things you can do with it, but it's got some application, and it's certainly something that you could use for that purpose. I don't know that I would necessarily host anything in this that required extreme acceleration. In that case, I might just go with a BSD VM or something like that, or enable hardware assisted virtualization, and that would make this speed up quite a bit as well. But in all cases, you end up with something that is usable for running software in a BSD context, which is a lot like Linux in a lot of ways. It's not exactly like Linux, but you get the same look and feel if you install XFCE on this as you would in Linux. So something certainly that you might want to check out in any case. So hopefully you found this to be useful for getting stuff like this up and running. I will put the images on Docker Hub, so you can use this particular image as well as the base image that I used for it. That is just qemu installed inside of a Docker container, which would work perfect for all things that we've been doing for Windows as well as FreeBSD, and this one, of course, for BSD as well. So certainly something that you want to check out. And I'll also link the repo where I have all of the code for this as well. So definitely check that out too. So thanks for watching this video. If you like this video, like and subscribe to the channel, and also share it with your friends, and drop comments in the comment section down below and let me know what you think. And if there's something that you want to see virtualized, I definitely might want to try it. Although I thought I was done with this, I just wanted to do one last one, and that was FreeBSD. And in any case, I think I'm officially done with this, but don't hold me to that. Anyways, thanks for watching.
If you like this content, please consider subscribing to the channel by clicking on the subscribe button. You can also like this content by clicking on the thumbs up, or share this content with your friends, and also comment in the comment section down below. You can also find me online at www.blaze.net or on Twitter at @theonemule. And as always, thanks for watching.